Hey guys, today we're going to be looking at creating what's called an IFE diagram. You'll see where the name comes from in just a minute. But this is a diagram that we use to analyze situations where we have gas pressure and some of the factors that influence gas pressure are changing. As an example, here we have a sample of gas under 9.76 kilopascals of pressure, and it's heated, so the temperature is changing from 294 Kelvin to 350 Kelvin. And what we're going to eventually start doing is solve and figure out exactly what the new pressure is going to be here, assuming that everything else stays constant. But before we do that, let's create these charts. So first, let's figure out where the name comes from. The I stands for initial. All initial means is beginning, or the starting setup. F stands for final, and E stands for effect. So initial, the beginning, final, the end, and effect, in which we describe how things change. Now I know that doesn't tell you anything yet. So here's what we're going to do. We're going to make a big box, and we're going to divide this box into 4 columns and 3 rows, just like that. And above these columns, we're going to put the names of the 4 factors that influence gas pressure. So stop and check yourself, see if you know what those are before I start writing them down, or the 4 factors, I guess I should say, including pressure. So first, the easy one, we have P for pressure, then V for volume, and this one is probably new as far as notation. We're going to say N, that's a lowercase n, and this stands for the number of particles, and capital T, which is temperature. So here we have pressure, and then volume, number of gas particles, and the temperature. Initial, remember, means beginning. So what we're going to do is, in this chart, we're going to go through and we're going to see what the pressure, volume, number of gas particles, and temperature was at the beginning. So we look, and before this change, notice there is a change here. We're going from the beginning to the end, and we can find that change in the problem. The change is this being heated. So we're wanting to know about all this stuff before the gas is heated. So before the gas is heated, it's under a pressure of 97.6 kilopascals. And so we write that in. So the initial pressure was 97.6 kilopascals. The original volume, well, the problem doesn't tell us anything about the initial volume, so we ignore it. We put a line in there. That's to say we don't know anything about it. Number of gas particles, again, we don't know, so we put a line through it. Initial temperature was 294. That we do know. Now we do the same thing for the final, that is, after it was heated. So after it was heated, we actually don't know what the pressure was. And the next step we're going to take after we learn how to build these diagrams is to use them to solve that problem. So if we don't know what it is, finally, but we knew the initial, just put a question mark there. Volume, we still don't know anything about. Number of gas particles, we still don't know anything about. But the temperature, we know, is now 350 Kelvin. And so now what we have to do is determine what effect this is going to have on everything else. And we just use up or down arrows. Up means the thing went up or will go up. Down means it's going to go down. So let's look at the temperature. Temperature went from 294 to 350. It went up. And for these, when they don't tell you anything about it, we assume that these don't change at all. Otherwise, the problem is not solvable. And so if you're doing these in a science classroom where people are setting problems up for you, these are just going to stay the same. So we don't have to worry about them. All we have to worry about now is what that pressure is going to do. And here's the way you can tell. Look at temperature. We want to know if the temperature goes up, what happens to the pressure. And the form of this chart itself can actually tell you how that works. So let's think of an imaginary line right down the middle of this. If you're comparing two things on opposite sides of this line, and sorry, that dotted line doesn't show up at all, does it? If you're comparing two variables on either side of this, they're going to be directly proportional, which means as temperature goes up, if everything else stays constant, pressure will go up. So the arrows will point in the same direction if the two things we're looking at are on opposite sides of this middle line. If they're on the same side, they'll go in opposite directions. So for instance, if for some reason we had a release valve that could get rid of atoms on this, as the temperature went up, if pressure and volume stayed the same, the number of atoms would have to be reduced somehow. But these are on opposite sides, so the arrows point in the same direction, and what this tells us is that the effect of temperature going up, it's going to cause pressure to go up as well. And we don't know how to figure out how much it's going to go up yet, but it's good to know that it will go up. So again, if they're on opposite sides of this line, the arrows are in the same direction. Let's look at another problem. Now, let's look at the second problem. A balloon with a volume of 0.5 cubic meters is under 101 kilopascals of pressure. What happens to the pressure if the volume is decreased to 0.3 cubic meters? So again, we're going to draw our IFE chart and try and establish what's going on here. So remember, the I stands for initial, the F stands for final, and E stands for effect. And we build our chart. And notice that because of what I said with this line here, it's important that you remember not only what these are, but what order they go in. So pressure, volume, number of gas particles, and temperature. And again, you will be responsible for constructing these charts out of your own head, so you have to remember initial, final effect, pressure, volume, number of gas particles, temperature. You need to memorize how to do these. All right, now we go through and we look at the initial situation before the change. Now what's the change? The volume is decreased. So before that volume is decreased, we want to know about all of these. So the pressure before the volume decreased was 101 kilopascals. The volume was 0.5 cubic meters, and we weren't given any information about the number of particles or the temperature. Now, after the volume was decreased, we don't know what the new pressure was. That's what we're looking for. So we'll put a question mark there. We do know that the volume is 0.3 cubic meters, and we're not told anything about the other two still, so we assume that they don't change. Now for the effect. We don't know what the change in pressure is going to be, but we do know what happened to the volume. The volume went down. And these two didn't change at all. So remember what I said about this line. As long as you've got these in this order, Everything on opposite sides of the line are directly proportional. That is, the arrows for the change will point the same way. When one of these goes up, one of these will go up. But when they're on the same side, they're inversely proportional. So when volume goes down, pressure goes the opposite way. Pressure will go up. So we don't know exactly what that new pressure is going to be yet. That's the next thing we're going to work on. But we do know that whatever that new pressure is, it's going to be higher than 101 kilopascals. Now this kind of makes sense. Imagine taking a balloon in your hand and squeezing it. It feels like it pushes harder on you the more you squeeze it. As you decrease volume, you increase pressure. So this sort of passes the common sense smell test as well. All right, to recap, drawing these IFE diagrams. The I stands for initial, the F for final, the E for effect. So there's your IFE right there. So we write those, and then we include all the variables of interest: pressure, volume, number of gas particles, and temperature. List what we know. If something's not listed, put a line through it and assume it stays constant. That is, it doesn't change. Initial is all our starting values before something changes in the problem. Final is after that change takes place. And the effect is whether or not that particular variable got greater or smaller. When we're comparing how one change affects the others, if they're on opposite sides of this midline, they're both going to be directly proportional, or they're going to be directly proportional to each other. So when one goes up, the other goes up, just as we see here. If they're on the same side, they're inversely proportional. So when one goes up, the other goes down. And that's about all there is to it.